Hello everybody and welcome. My name is Sergio Agustin Gallego and I'm going to show you how to define an NCAP scenario in ASAM OpenSCENARIO Standard. NCAP stands for New Car Assessment Program and provides a set of safety tests for vehicles. OpenSCENARIO Standard uses files with XML format. With Scenario Designer, the OpenSCENARIO standards are met and the file's definition is performed with a graphical user interface. That makes the process fast and user-friendly. Let's start with the generation. Well, at this point, it is necessary to give an explanation about which concrete NCAP test is going to be built in our Scenario Designer. And for that, this is the documentation. Well, that's the test. CPNCO50, car to pedestrian nearside child obstructed, 50%, which is a collision in which a vehicle travels forwards towards the child pedestrian crossing its path running from behind an obstruction. From the near side and the frontal structure of the vehicle strikes the pedestrian at 50% of the vehicle's width when no braking action is applied. So here it can be seen the sketch for this test, where all these dimensions are predefined and specified and must be that way, and also other data that will be taken as input for our scenario build is shown here in this table, where you see that that's the test that is going to be built. It consists of an automatic emergency braking system test, and the vehicle under test speed shall be between 10 and 60 km/h, the target speed, which is the one of the pedestrian, 5 km/h, and here again the impact location. So now we can shift to our Scenario Designer. That's the first view that one gets. And as a first step, we have to import our road. That's the default road. But we need an NCAP compliant road, which is specified in here. OpenDRIVE file. Okay, that's the road. And now what we can do is import the entities that are involved in the scenario. That can be done from here, the components pane, or we already have some predefined catalogs for that. So our vehicles catalog is going now to be imported. Also the pedestrians catalog, which is only one pedestrian, but with some concrete data like dimensions, and also the trajectory that the pedestrian is going to follow. Okay, by clicking at import all, now under catalogs we have all these entities. But now they need to be used also in the scenario, and for that we shall copy them from the catalog to the entities that are used in the scenario. Now the entities are copied. The same should happen for the trajectory. And now the parameterization can start, the positioning. Okay, so for that, we again need to consider the NCAP inputs, which are defined here. The Excel is something that has been used for showing purposes. This also can all be scripted in the Scenario Designer instead of using an external Excel for get the data. But this way it probably gets more clear, the whole process and which quantity is what. Okay, so those are NCAP inputs. 4 distances and 2 velocities. These are the 4 distances, and the 2 velocities, the speed of the vehicle under test and the pedestrian speed. Then for Scenario Designer we also have some inputs, which are the dimensions of the vehicles and of the pedestrian, the relevant dimensions at least for performing our calculations. So under distances we have the initial positioning calculations to get the scenario this way, and under EPTC we have our pedestrian calculations, which are going to be explained after. Okay, so first of all, we are going to position our pedestrian. For that, we can start setting an X displacement. All is going to be relative to some other entities in order to, that the story does not change if the initial positioning of the ego is varied, for example. And yeah, for that we can start with the pedestrian, setting here initial positioning relative to object. The object is the ego vehicle or vehicle under test, and an X displacement of, for example, 140 is applied. So now we can see here is a pedestrian. It can be seen directly that the heading is not as it should be, so it can be changed easily. And again, this distance, the lateral displacement, is also defined by the NCAP tests as 4 meters. So -4 can be specified here. Pedestrian positioning is completed. Now the car 2 is going to be defined relative to the pedestrian. For example, it is how it has been done here. So relative object to the pedestrian. For that we also need some calculations, which are, first we can start maybe correcting again the heading. And now we start with the positioning. First, for the lateral distance, what has been done is the 4 meters, this 4 meters, okay, minus this distance here, which should be half of the length of the vehicle, half of the length of this vehicle, and 1 meter. And altogether is 1.215. So this quantity here should be 1.215. Exactly. And now the Y displacement. For getting this distance, which is this one here, we need the vehicle length, this one, and this distance. Since the reference system of the car is here at the center of the rear axle, we need to subtract this quantity here, and that's what this number here is. For the Excel, it has been set up this way, but when scripting, this quantity can also be extracted automatically from the Scenario Designer. And 4.467 is the value. So minus 4.467. Yeah, either way, plus. So that's easy to check with Scenario Designer. Okay, this positioning is also completed. And now we can have the positioning of the third entity, which will be, again, relative object. And now, in order to be easier the calculations, to car 2. So now, when looking at the entity, we have again that this distance should be 1 meter, and the length shall also be considered, which is specified here. So with length and distance, we get 5.313. So this should be minus 5.313 meters. And the positioning is completed. Now the trajectory, in order to be in the correct place, and what we can do for that is parameterizing this quantity so that it gets automatically updated each time that maybe the pedestrian is at a different point. So for that, we can just with right click assign a parameter, which will be x for the pedestrian, and using it here in the trajectory for the x distance. So now the trajectory is at its correct place. Okay. And the same should happen for the y displacement at the starting point of the trajectory. So y APTC, and the starting point is 0.1. Here it's also predefined, but now it's subject to any change and will be automatically updated also. The story can begin, the acts can begin. And yeah, here is where every action is defined. These are maneuver groups, and you can define multiple maneuver groups. Actually, we will need multiple maneuver groups, so I preset them. On the first maneuver group, it should be defined one actor. The actor is the one that will perform the actions. So first, the vehicle under test, or ego, is going to be defined as the actor, and the first maneuver will be defined as speed changes, everything that is related to speed changes. So we can change the name. Okay, this action here, yeah, should be here. You can define the trigger of the action, and here the action. So the action will be a speed change for accelerating at the beginning, and yeah, this speed change is now starting with the story. And if you want to define another trigger, you can just here add a condition. For example, we set simulation time to 1 second. When the simulation time becomes with a rising edge greater than 1 second, then the action starts. 50 is a speed that we saw that is in the range from 10 to 60 as defined for the NCAP test. And now this is the acceleration. We can do it with a rate, for example, for a quantity of 3.5 meters second squared, because if the NCAP test needs a constant speed of the ego vehicle, when the pedestrian starts walking, in the end, the events here should not overlap. So this speed should be constant in order to be the test performed properly. Okay, so now we can rename this to acceleration event, acceleration. And a second speed change event is going to be defined. And this will be the braking. For the braking, it goes to 0, the velocity, and also a rate is going to be defined. That's also input from the concrete NCAP test, which is for the automatic emergency braking, and normal values are around 7 meters squared second. 7, 8, 9, 7 is maybe a good quantity. It can also be varied anytime. So, and this will start when, now this is the point at which the automatic emergency braking gets activated. So we are going to set it with a relative distance trigger condition, and this relative distance is going to be computed between the vehicle under test and the pedestrian. So free space is evaluated, which is, instead of the space between the coordinate systems, this free space condition means between the free space. So in this case, it would be from, for example, for this vehicle, from the front of the vehicle to the left arm of the pedestrian. Okay, and longitudinal distance is what we want when it becomes less or equal than, for example, 20 meters. So the braking event is defined. And that was it. And now we can do similar with the pedestrian. The actor for these maneuver groups is the pedestrian. And we are going to have also a speed change maneuver, which consists again in an acceleration, which will be from 0 to 5 in 1 meter, as defined here. G, 1 meter, is the dummy acceleration distance, so the pedestrian acceleration distance. And this will be 1 meter. The trigger of this action will be defined with a relative distance condition between the ego vehicle and the pedestrian. Okay, and which distance should be this? And this is the distance that is going to be calculated here. So for that, it is as simple as that these distances are all known, and the velocity profile of the pedestrian is also known since it starts working. The only unknown is the point at which it starts working. So going backwards, we have the time to collision, because we have the distance and the velocity. So the time to collision gets calculated here, 3.6 seconds. And with that and the vehicle under test speed, one can get the distance to collision. So the distance of the vehicle to this point, so that the pedestrian needs to start working and the collision happens at this point. And this is, for this case, 50 meters. So this is 50 meters. When it becomes less or equal than. Okay, that's where the pedestrian starts walking. And these are the ego events. Now, for the pedestrian to start walking, we also need another event, which would be the trajectory, follow trajectory. Okay, we might define a new maneuver for that. New maneuver, which will be trajectory. And now, follow trajectory action. The trajectory is this. Perfect. And the trigger is again the same, relative distance. When it becomes less than or equal 10. And here, for doing that, we can also parameterize the same as we did before, this quantity. So we assign this relative distance, the triggering distance parameter. Here we generate a new parameter. Define as trigger distance, so that we can also use it here and it gets automatically updated. Perfect. Now everything is defined, and the only thing that is necessary for completing the story, the entire story, is a stop for the collision. When the collision happens, our entire simulation should stop, and that is something that needs to be defined under settings. Here is our stop trigger. Currently it's a time limit when it reaches 40 seconds, and we are going to set it up with a collision between our ego vehicle and the pedestrian. Okay, so when the collision happens, now it should stop. But since we have this braking condition, it's supposed to not happen. Yeah, as shown here. For checking if we built correctly the scenario, now we can deselect this braking condition, which is here. And yeah, the collision seems to happen here. The collision happened. We can replay the scenario from the beginning. By selecting these two, we can fix the view so that the camera follows them. And there we have the vehicle under test accelerating. Here in the time it can be seen. Now it is in a constant speed phase, so the test is correct, and the pedestrian starts walking. And when the collision happens at 50% of the width of the vehicle, the simulation stops. So the test is correctly performed. And now our two only variables for performing different cases are the speed of the vehicle under test, the target speed, and this relative distance, the trigger relative distance at which the pedestrian starts walking, 50 meters. So with those two parameters, now we can generate different cases. Here under the parameters tab, one can, okay, only the trigger distance is parameterized, so we need to parameterize also the speed. Now it is parameterized. And we can move them from parameters to scenario set. Now we are in the scenario tab, and the scenario set, another parameter needs to be considered for the scenario set that we want to define. Okay, trigger distance and target speed of the vehicle under test. And with those two, now we can define different scenario sets. For example, 3 we are going to define. One for 40, as we saw in the Excel, if that changes this way, if the vehicle under test speed is 40, this distance is 40, 50-50, and 60-60. So they vary the same way. We can set that here as 40, this one here as 50, and this one here as 60. The same for the names, 40, 50, and 60. And now under cases, we can, by managing our parameters, include the scenario set so that we can change here which scenario, which case is going to be simulated. And we can generate 3 different cases. Again, the case of 40, 50, and 60. Selecting the correspondent scenario set. And now with that, here under home, we can change these values so that the entire scenario changes depending on the speed. And if we again make the braking off, at first we had 50 as a speed, now we have 60, and still the collision happens at the same point, so it gets updated automatically. And another interesting feature is that now we can export all these cases to a folder. Here we have everything. That's how these XML files look like, and are OpenSCENARIO compliant. This is OpenSCENARIO compliant, everything. So, which means that it can be simulated in other environments, like for example, 3D environments, as it is ES Mini. And for that, we have our small script where it needs to be defined the ES Mini execution path, the OpenSCENARIO file that is going to be simulated, and with a simple run order here for example, the 40 case. Yeah, let's do the 60 case. We get an ES Mini replay of the action, so that it can be seen in a 3D environment. And when the collision happens, the simulation stops. And now the scenario is completed, and this has been done with the Excel calculations. And as I said before, I could now show maybe briefly that it can also be done with a script, so that everything is computed internally in the Scenario Designer and no external applications are needed. Further parameterization has been necessary, as one can see, and here under scripts one can find the code. So with this code, now everything is executed the same way, and these parameters are fixed by the code, which is also done this way so that some parameters cannot be changed. For example, like the NCAP inputs. Now these NCAP inputs that are defined here cannot be changed in the scenario, since they should be remained this way. And for example, we can show how it behaves to certain variations, like I don't know, for the car 2, for example. Now the width is changed to 2.5 meters, which is pretty much. Everything is going to be updated and calculated internally, and yeah, that's the same but parameterized and with cases. And that should be everything about how to build an